Imagine you are in an interview. The interviewer prepared three questions. Two of them are hard questions, but one of them is easy. They are placed in three envelopes and you can choose one of them. Naturally, you would like to choose the easy question to improve your odds of succeeding the interview. But at this point, you have no idea which one is the easy one. So you pick randomly an envelope. Then something interesting happens. The interviewer removes one of the envelopes and explains that the removed envelope contained a hard question. The interviewer then asks you, would you rather like to switch to the other envelope or stay with your initial choice? You're now confused about this unusual interview process and ask yourself what I should do. You quickly realize you have two options or two strategies if you were about to participate in this interview many times. In fact, you would like to choose the strategy that has the best probability of success. This problem has actually a name and it is called Monty Hall Problem. Now the question is which strategy to pick. In order to answer this question, we should look at the probability of success for each of these strategies. The first strategy of picking an envelope and sticking to it is pretty straightforward. There is a one-third chance of hitting the easy question in the interview. But what is the success probability of the second strategy? Is it one-third since anyway we switch to the other box and we have three boxes initially? Or is it half since after removal of one of the harder questions by the interviewer we end up with two envelopes? Or let me propose another guess, although counterintuitive, and that is two-thirds. But what is actually the probability of success? You can think of probability of success as playing this game many times according to a strategy and each time record if you hit the easy question or not. Then the ratio of number of hitting the easy question divided by total number of games can be considered as an approximation for the probability of success. For example, if we play the first strategy, we might get the following outcomes and success ratio. Now the fun parts start. I'm going to use a computer simulation to run the first strategy many times and see what the success ratio is. As you see, the ratio is converging to one-third, which matches our guess for the first strategy. Let's now run the same simulation for the second strategy. But before that, let me recall how it works. We pick our initial guess, the interviewer removes a hard question, and we always switch to the other remaining question. And that will be our final choice. And this is crucial. We always switch to the other question. Very interesting. The ratio is now close to two-thirds, twice as the first strategy. This shows that second strategy has much better chance of resulting in the easy question. I would like to end this video with two questions. Firstly, why the second approach gave us a higher chance of success, namely, probability of hitting easy question using first approach is only one-third, but the second approach is twice as much, or two-thirds. Second question is, why our approximation of probability of success is valid? I leave some links under this video if you would like to read more on this problem and find answers to these questions. Thank you very much and I hope you enjoyed this video.